So yesterday we started with proportions and ratios. Today we're going to solve them using cross products. Cross products are a nice little shortcut. So this is only used when you have only one fraction on each side of the equation, and it has to be an equation. If you have just two fractions like this, you don't use cross products. But when they're equal to each other, then we can use cross products. So this will save us flipping things around and messing around with the fractions. All you do is multiply in a cross formation. You multiply the numerator on one side by the denominator on the other side. And when you do that, you have to come up with equivalent products. 8 times 15 has to equal 6 times x. 8 times 15 has to be equal to 6 times x. What is 8 times 15? Ryan?
120.
What's that?
120.
What's that? 120.
Oh.
Okay. Then what do we do? Yes? Divide both sides by 6. Leaves us with x equals 20. X equals 20. Now this is also helpful when we have more complicated fractions. As an example 2, we have 4 over x equals 8 over x minus 3. So we cross multiply, but you have to be real careful. The 8 times x should be pretty simple, but we need to make sure when you do 4 times x minus 3 that we use which property? The distributive property. What do we get when we distribute on the right?
4x and 12. Or negative 12.
4x minus 12. What's our next step in solving? Ryan, you got all the answers today.
Add 4x to both sides. Subtract.
Now we know where you're getting the answers. All right, so subtract 4x from both sides because it's a positive 4x, so we get rid of it by subtracting. Oh. Yeah. So we have 4x equals negative 12. What do we do now? Divide both sides by 4, and we get x equals negative 3. Everybody good so far? Now, this was in the book, it's a multiple choice question. How else could we find the answer? How else could we find the answer in a multiple choice question like this? Yeah. We could plug in each number into the equation and see which one comes out true. Okay. Let's look at example 3. Each day, the seals at an aquarium are each fed 8 pounds of food. That's a lot of food. For every 100 pounds of their body weight. Holy cow. I wonder how many pounds of food I don't want to know. For every 100 pounds that they weigh, they eat 8 pounds of food. A seal at the aquarium weighs 280 pounds. How much food should the seal be fed per day? So it should be pretty easy to see that we can set up our proportion for this. Okay? So a seal eats 8 pounds of food. When do they eat 8 pounds of food?
Every day.
Yes, but what's the qualifications for them to get 8 pounds of food? If they weigh 100 pounds. That's our first ratio. 8 pounds of food to 100 pounds of body weight. Okay. Now, we need to know how much food. Okay, so notice on the left we had food on top and body weight on the bottom. On the right we need food on top, body weight on the bottom. So we don't know how much food they're going to eat, but they have a body weight of 280 pounds. So we've set up our proportion. 8 over 100 equals x times 280. So now we cross multiply. 8 times 280
2,240.
Yeah, I don't know where I was going. Blinked out there for a second. And then we have 100 times x. What do we get when we divide? 22.4 pounds of food for that seal. That's a lot. I guess if you think about it, it's not too much. If they're eating a whole fish, right? Like if you give them a whole fish, a 22-pound fish isn't that substantial, but no, it's big, but it's not like huge. It's still a big fish. My wife went to all the trouble of making a big plate of fried chicken for the dolphins at the aquarium. And the guy was like, you can't give them fried chicken. They only eat fish. And I was like, well, of course they only eat fish if that's all you give them. Seriously. All right. Now, we use proportions in scale models and scale drawings for different diagrams. For instance, blueprints for making, for putting together a house or making various, I don't know, cell phones, whatever you want to make. You have a blueprint for it that blows it up to show you exactly what you're looking at. So for small things, your blueprint's bigger. Like you might have a big poster with the blueprints of a cell phone. But for a house, it's smaller because you can't read a blueprint that's the size of a house or bigger. That'd be kind of pointless. So we use a scale to represent what the lengths on the scale drawing equate to. So for instance, we could have a scale model of a house, or a blueprint of a house that says 1 inch to 12 feet. That means that on the blueprint, every 1 inch measurement is equal to 12 feet. So if there's a room on that blueprint that's 2 inches long, that equates to a room in the house that's 24 feet long. Okay. We also see this on maps. So suppose we have a map of the state of Ohio, because for some reason you want to visit Ohio. Apologies to anybody that might listen to this on YouTube that's from Ohio. I mean, I guess you could go to the Rock and Roll Hall of Fame, or you go see a Bengals game. Does anybody watch those? Or the Browns? I don't know why you would, but somebody has to watch them. They're still playing. That's too bad. I'm sorry. My condolences. So we have this diagram. Now it's going to be real hard if you're watching this on the video to measure with a metric ruler. But if you take out a ruler and measure the distance between Cleveland and Cincinnati, if you have your ruler and we measure that in metric, and we know we want to use metric because the scale down at the bottom says 1 centimeter, 85 kilometers. So if we measure that with our ruler in metric, how far is it in centimeters from Cleveland to Cincinnati? I'm sorry? Around 4? 4 what? 4 point, about 4.2-ish? So it's about 4.2 centimeters. We want to know how many kilometers that equates to. Now we know from the scale given on the map that 1 centimeter equates to 85 kilometers. So we cross multiply. And we have x equals 4.2 times 85. Well, 4 times 85 would be 340, and then 0.2 times 85 would be 17. So 357 kilometers? Yes? Is that what your calculator says? Awesome. So the distance from Cleveland to Cincinnati is approximately 357 kilometers. So we found that using the scale that they gave us on the map and then setting up a proportion. Any questions? Okay.